Prime numbers, divisibility tests. Divisibility tests are tests to determine if a number can be divided exactly by another. So we have some divisibility tests. So the first one is 2. So the first question we ask, is the last digit even? Which is kind of what we've gone over before in the last video. And so this is any integer ending with 0, 2, 4, 6, or 8. So the question would be, would 32 be divisible by 2? And the answer is yes, because it ends with the digit 2. Next, we look at 3. So we look at the sum of the digits and we see if it's divisible by 3. So we could ask, would 381 be divisible by 3? So this becomes a lot easier if we know this. So if we can go 3 plus 8 plus 1. So the sum of the digits, so there's 3 digits, 3 and 1 in this, so we just add them together. So 3 plus 8 is 11, plus 1 is 12. And then we look to see if it's divisible by 3, and it comes out to be a whole number, which it does, which is 4, because 12 divided by 3 is 4. So the answer is yes. It is divisible by 3. The next one is 5. So we can ask, is the last digit a 0 or 5? Because if it's either of those, then it's divisible by 5. So would 90 be divisible by 5? And the answer is yes. The last digit is 0. Now, for the other prime numbers, which we talked about in the first video of this section, we are going to use long division. So now let's look at some examples. Example 1. Eggs come in cartons of 12 or 18. 12 is divisible by which prime numbers? Well, for this problem, we're going to go over all the divisibility tests that we know. So the first one we're going to look at is 2. So we ask ourselves, is 12 even? Therefore, can it be divided by 2? And the answer is yes. It is even, so divisible by 2. The next one is 3. Well, for this test, we can look at the sum of the digits. So we go 1 plus 2, because of those are the 2 digits, and 12. So 1 plus 2 is equal to 3. And if we divide by 3, it's equal to 1. So we get a whole number. So we would say, yes, it is divisible by 3. The next one we look at is 5. And we look to see if it ends with a 0 or a 5. Well, 12 ends in 2, so we would say no. It is not divisible by 5. Then we know the next one, prime number is 7. And 12 can't be divided by 7, so we would say no. The next one would be 11. So that's also no, because 12 divided by 11 would give us a decimal number. It doesn't go into it evenly. It does not give us a whole number. So we could say 12 is divisible by which prime numbers? We would say 2 and 3. So those are the prime numbers that it's divisible by. Now let's look at another example. Example 2. So eggs come in cartons of 12 or 18. 18 is divisible by which prime numbers? So we're going to go over the test again. So we look at 2, and we see that 18 is even because it ends in an 8. So it's divisible by 2. Yes, it is even, so divisible by 2. Then we look at the next one. So we look at 3. We have to look at the sum of the digits. So we can go 1 plus 8, which is equal to 9. Now 9 divided by 3 is equal to 3. So we would say, yes, it is divisible by 3. We look at 5. Well, it's 18. It doesn't end in a 0 or a 5, so we would say no, it is not divisible by 5, as it does not end in a 0 or 5, as we just said. Then we look at the next prime numbers. So we can look at 7, 11, and probably anything after like 13, it's not going to work, because 18 divided by 13, it wouldn't be whole. So we can write that out. So any number after that, it won't be. Now we look at 7 and 11 first. So let's look at 7. Well, if we did, 7 times 2 is equal to 14. So it's not going to be divisible by 7, because 18 divided by 7, it doesn't give us a whole number. So we would say no. Now 11. 18 divided by 11. That also doesn't work, because it doesn't give us a whole number. So we're looking for numbers that can go into this and give us whole numbers. And these are only prime numbers. So the only prime numbers in 18 is then 2 and 3 again. These are the prime numbers. Now let's do one final example. Example 3. 35 is divisible by which prime numbers? 35, let's look at this. So we have 35. Let's look at 2. Now, does it end with an even digit? And the answer is no, because 5 is odd. So we would say no, it is an odd number. So if it was even, we would say yes, but this one's odd, so no. Then we look at 3. How we determine this is we look at the sum of the digits. So 3 plus 5 is equal to 8. And 8 actually can't be divided by 3, because it would give us a decimal. So it doesn't give us a whole number, so we would say no, it is not divisible by 3. Then we look at 5. Does it end in a 0 or a 5? And the answer is yes. Then we look at the next prime numbers. So we look at 7. Well, if we look at 35, we have to use either long division, or we can know that 35 divided by 7 is equal to 5. So the answer is yes, it is divisible by 7. Then we look at the next prime numbers, 11. Well, 11 times 3 is 33. So this is 35. So we would say no, it is not divisible by 11. And we can stop there, because we know that it's just 5 and 7 that can make up 35. Those are the only prime numbers. So The prime numbers are 5 and 7. Now, this is important when we start looking at fractions and trying to reduce fractions. So this is why we are going over these divisibility tests, as they will help.